Right, for our next question, they gave you an object B, and then they said there are two forces acting on it, which is your 2.5 newtons here and your 7.5 newtons. And they also gave you the directions in the sense that 2.5 newtons is actually acting at 30 degrees, 7.5 newtons is vertically upwards. So to find the first part, they said draw an arrow to show the approximate direction of the resultant. So once again, we draw the first vector. So let's say we use back this vector, which they drew for us, 7.5. Now, if you're drawing to scale, you may actually draw it longer or shorter, it's up to you. So if you are drawing to scale, you can adjust according to your scale. For example, if you're taking 1 centimeter to 1 newtons, then you can make sure that this is 7.5 centimeters. So you draw as long as you need, or you only use a portion of the line, it doesn't matter. But anyway, so for this method, I'm just sketching, so I'll just use this line as a reference, and then from where it stops, I must draw the second vector, which is the 2.5 newtons. So I draw the 2.5, just estimate. So therefore 7.5 plus 2.5, the resultant will be joining from beginning to end. So this is my approximate direction. Then the next part asks you to find the magnitude of the resultant force. So since you know these two forces and you know the angle, which is 60, so how do I know this angle is 60? Because if this is 30, this is 30, so this is 90, so this in the bottom will be 60. So we can use the formula, the cosine formula, which is FR squared equals to 7.5 squared plus 2.5 squared minus 2 times 2.5 times 7.5 times cos 60, and you will get the resultant force. And if they ask you to find the acceleration, now remember in physics, acceleration goes together with net force. So net force equals to ma, so your net force is 6.61, your mass is 750 grams, so you can find the acceleration. And the next part is to find the angle between the acceleration and the direction of the 7.5 newtons. Now don't forget, the direction of the acceleration is also the direction of the net force. So basically, they're asking you to find the direction of the resultant force or the net force from this vertical. So how do we solve? We can use the sine formula. So since we know that this FR is already 6.61 newtons, so we use the sine formula, which is 2.5 over sine theta equals to FR, which is 6.61 over sine 60, and you will get the theta as 19.1 degree. Now, in case you want to draw and solve this question by drawing to scale, so what you would do is perhaps you set a suitable scale. Let's say 1 centimeter is to 1 newtons, and then you take your ruler and measure this vertical line and make sure that it is 7.5 centimeters. So you may have to extend it or shorten it, it doesn't matter, you just use 7.5 centimeters, and where it stops, you take out your protractor and measure 60 degrees, and then you measure 2.5 centimeters. Then you just draw a line from beginning to the end, and then after that you measure the length of this line using your ruler, and your conversion is 1 centimeter to 1 newton. And then to find this angle, you can also take out a protractor and just measure the angle directly. You don't have to do any calculation. Now if you are solving by using drawing to scale, they will accept a larger range because they recognize that it's not so accurate. So no worries, it will still be correct if your answer is slightly different. Right, for our next question, they mentioned that there's these two tugboats actually pulling a tanker at constant velocity. All right, so they said the force, the T1, the angle is given, T2 angle is also given, and together T1 and T2 gives you this resultant force, which is 25,000 newtons. And by reference to the forces acting on the tanker, explain how the tanker may be described as being in equilibrium. Now we do know that the tanker is in equilibrium because it is moving at constant velocity. So according to Newton's first law, it will be in equilibrium. So how can it be in equilibrium since the two forces here, T1, T2, gives me a resultant of 25 times 10 to the power 3 newtons? It means that Now, first of all, you need to understand that this T1, T2 gives me a resultant of 25 times about 3 newtons, means I can replace these two forces with a single force of 25 times 10 to the power 3 newtons. So therefore, to make this tanker to be in equilibrium, we put another force in the opposite direction, same magnitude, which is 25 times 10 to the power 3 newtons as well. Then these two forces will cancel out and you will be in equilibrium. So what force could possibly act in the opposite direction? Of course, it will be your drag force. So therefore, you can mention this. Sum of T1 and T2 gives a resultant force, which is this, which is equal in magnitude and but opposite in direction to your frictional force. So your frictional force will be opposite direction, but also having the same magnitude. Then it will cancel out. So the next part asks you to complete the question by finding the values of T1 and T2. So the way we draw this vector triangle is a bit different, because for this question they already gave you the resultant and you are supposed to draw the components. In the previous question they gave us the component and we find the resultant, but no worries, it's the same concept. So let's say this is my resultant. Now you may draw to scale, for example, or you may sketch it out. So for example, if you're drawing to scale, let's say I set 1 centimeter is to 2000 newtons, so 25,000 newtons divided by 2000 newtons will give me about 12.5 centimeters. So I'll just extend this line until I get 12.5 centimeters, and then what will happen is I will start drawing my components. So I know this is my start and this is my end of my resultant, so T1 must start from here. So you measure 25 degrees with a protractor and draw T1 as long as you need to, and then we have a problem because we don't know where to start drawing your T2, because T2 by right you must start drawing it from where your T1 ends, but we don't know how long to draw your T1. So what we do is we don't know where to start your T2, but we do know it will end at the end of R. So from R we go at the end of R, we work backwards, we measure 15 degrees and we draw a line backwards to represent T2, and you will notice that they will cross and you will rub off the excess, you erase the excess. So that will be your proper vector diagram. You take out your ruler to measure this, and then you measure in centimeters, you times your scale to get how many newtons. You measure this in centimeter and times this scale to get in newtons. But if let's say you don't want to draw to scale, you just want to sketch it out, so you do the same thing. You just draw a line here to represent the R, then you draw T1 starting from here, and then we just roughly guess that this would where T1 ends. Then we start drawing T2 and then we will complete the diagram. So this is just by estimation, but then we will calculate the T1 and T2 using the sine formula. So T1 divided by sine 15 equals to T2 over sine 25 equals to your resultant, which is 25,000 over sine 140, and from there we can get your T1 and T2.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie, we'll see you next time. Bye-bye.